Okay, in this video, we're going to bring it all together and graph more complex secant, cosecant, tangent, cotangent graphs. Get in the things that vary by period, and that idea of amplitude we'll be bringing in as well. Now, I'm just going to go ahead and get right down to the nuts and bolts. Here we go. So our first equation is y equals 2 cosecant 3 theta. So I'm actually going to do the same exact process we did in the graphing sine and cosine with the period and amplitude. I'm going to do the same process. I'm going to identify A and B and then figure out the period. So here we go. First of all, A here is 2 and B is 3. And the bottom one here, I have an A of 1/2 and a B of also 1/2, dividing by 2. Okay. And so then when I actually go to calculate the period here, I'm going to, in this case up here, I'm going to have the period is equal to 2 pi over B, which is 3. And down here, I'm going to have the period is 2 pi over 1/2, but dividing by a fraction is like multiplying by its reciprocal. So it's multiplying by 2. So the period down here is 4 pi. Okay, so now I've got my amplitude and my period. And what I'm going to do is I'm not going to go straight away and just graph secant, cosecant. I'm going to graph the reciprocal. So the reciprocal of cosecant is sine. So I'm going to graph that one. So using those principles from before, I'm going to go to I'm going to have 4 marks. That's what we had last time. And then we had our period. So 1, 2, 3, 4. That would make this 2 pi over 3, which would make this halfway point pi over 3. And make, if I go here, that would be 3 pi over 3 or just pi. So I've got some indicator marking here. The amplitude here is 2, so I'm going to go 1, 2, -1, -2. And so I've set up this grid specifically for graphing sine. Now, on the one below, I'm graphing secant, so the reciprocal of that is cosine, but the same setup. So what's my period? My period's 4 pi, so I count 1, 2, 3, 4. I make that 4 pi, which then makes this halfway point 2 pi. Every mark now is pi. Well, what's my amplitude here? Well, it's 1/2. Well, I don't have to go and make these vertical lines equal to 1. I could make this bottom one equal to 1/2 and make that top one 1. Right? So -1. So it makes it nice that I have this nice half mark to work with. So go ahead and change the scale to sort of fit what you're graphing. It makes it much easier to do so. And then what I'm going to do is I'm going to go in here. Let me choose purple, and I'm going to go light. And I'm going to lightly dash in the sine and cosine graphs. Now, I remember that with sine, I start in the middle, then go to the peak, back to the middle, down, back to the middle, that cycle. But with cosine, I start at the peak, and then go to the middle, and then down. So it's a different starting point. So here's the first one's cosecant, so I'm going to do the sine pattern, which is middle, top, middle, bottom, middle, top, middle, bottom, and so on. I'm going to do the same thing here for secant, but the reciprocal of that is cosine, so I'm going to start at the peak, and then go to the middle, and then to the bottom, just like we did with all the cosine graphs. And my peak here is 1/2, because that's my amplitude. Okay, so then next, I'm going to go ahead and draw in all the asymptotes. Now, if you remember, the asymptotes of these ones from a previous video are when sine and cosine go through the middle. That's when cosecant, in the case of sine, or secant, in the case of cosine, have an asymptote. As you get closer to 0, numbers get larger when you divide by a tiny number. Anyway, so basically everywhere where sine goes through the middle, I'm going to draw an asymptote. Everywhere where cosine goes through the middle, I'm going to draw an asymptote. So then now here in red, I'm going to graph the graphs. So notice that I actually didn't graph all of sine, all of cosine. You don't actually need to do this. Just graphing the peaks, the middles, and the valleys gives you enough information to go ahead and graph secant and cosecant. So basically, we're going to, any of those peaks, we're going to turn into valleys and go up the asymptotes. And any of those valleys, we're going to turn into peaks, go down those asymptotes. So here we go. We're going to graph these secant and cosecant graphs. For example, this point right here is a peak in the sine graph, so it is a valley in the cosecant graph, and the cosecant graph is going to go up these asymptotes. Whereas this point down here is a valley in the sine graph, so it's going to become a peak in the cosecant graph and go down the asymptotes, and so on. And there you go. There's how to graph cosecant and secant given the amplitude and period of the sine and cosine graphs related to them. All right, let's go ahead and move on to tangent and cotangent. Okay, so here we go. First of all, you'll notice in both of these ones, I didn't put a number in front for the amplitude. It does affect the shape of tangent and cotangent, but not in a way that's really easy to like quantify and that we're really going to worry about in detail here. So we're really going to, when we deal with tangent, cotangent, we're not going to deal much with having a multiplication and a vertical stretching on the outside. We're just going to deal with them as is. However, their period is something we are going to focus on. And that period formula again for tangent and cotangent is pi over b. So here we go. I'm going to identify what b is in each of these. So in this one here, b is 6, and here b is 7/4. I'm going to plug them into the formula that is pi over b. So in this case, the period is pi over 6. And in this one, the period is pi over 7/4. And I know that dividing by a fraction is like multiplying by its reciprocal. And so I get that the period is 4/7 pi, or 4 pi over 7. Now, the principles in graphing are just a little bit different here. Because the period happens twice as quickly, instead of going out 4 tick marks, we're going to go out 2, because every 2 is it's going to repeat itself. So I'm going to go here in the first one here, and I'm going to write in pi over 6 here at the second tick mark, and in the other one I'm going to write 4 pi over 7 here. Okay, and then if I want to double that, this would be 2 pi over 6, which reduces to pi over 3, and then 3 pi over 6 reduces to pi over 2. So I can actually kind of reduce these numbers as I go along. But down here, double 4 pi over 7, well, that's 8 pi over 7, and that doesn't reduce. And so these ones don't reduce at all. Okay, as I keep going on, I'm adding 4 pi over 7, which just adds 4 to the top. Now we could go ahead and graph sine and cosine and do that whole complicated mess we did before, but there's actually a faster way just based on the patterns that we saw in just the tangent and cotangent functions. If you go back to the other video, you'll see that tangent passed through its middle when it started, and then the next tick mark over, there was an asymptote, and it went up that asymptote. And cotangent basically did the exact opposite. Instead of starting in the middle, it started at an asymptote, and it went down that asymptote to the middle on the next tick mark. So I'll show you how that works. So I'm going to go ahead and draw our asymptotes first. I'm going to draw a vertical asymptote on tangent, not at the origin, but the very next tick mark. And then the next one I'm going to skip because that's a middle one. And so every other one of these tick marks on tangent is going to get a vertical asymptote. Okay, so tangent has a middle point to start and then a vertical asymptote, and cotangent's the reverse. So in the middle, I'm going to have a vertical asymptote, and then every other one's going to have a vertical asymptote. Show you how that works. Okay, and then what we said before is that in between those asymptotes, there is a middle point in between all of them. So for both tangent and cotangent, they go through a middle point right halfway between the asymptotes. That's what we saw in the pattern. And the difference between tangent and cotangent after here is that tangent goes up when it goes to the right and down when it goes to the left, whereas cotangent on the left side is going up and down on the right. So let me go ahead and finish that out. Okay, there you go. Cosecant, secant, tangent, and cotangent graphs, and their patterns. And I'll be seeing you hopefully in a live webinar to give you some more examples and to answer your questions. See ya.